Let us study continuous probability distribution. In our syllabus, we will be studying normal distribution. A random variable is a variable that contains the outcome of a chance experiment. For example, we consider an experiment to measure the arrivals of cars at a toll booth during a 60-second period. The number of cars that would arrive at the toll booth would be 0, 1, 2, 3, so on. Now here the random variable x can take any discrete values. It takes some finite countable values, non-negative whole numbers. Now, for example, if you have another experiment in which a person is assembling a product and we are interested in the time it takes to accomplish this task. So the random variable here is maybe the time taken to assemble the product would be 3.5 minutes, 3 minutes, 4 minutes, 5 minutes, okay, 3.6 minutes, whatever. The experiment in which things are measured, not counted. For example, time, weight, height, volumes yield a continuous random variable. Once a data is measured and recorded in actual practice, all the data is discrete. The continuous distribution in data analysis is used where data originally is continuous. The outcome of the random variable and their associated probabilities can be organized into distributions like probability distribution of discrete random variable and probability distribution for continuous random variable. The outcomes of random variables and their associated probabilities can be organized into distributions. The two types of distributions are discrete distributions constructed from a discrete random variable and continuous distribution based on continuous random variables. In our syllabus, as far as discrete distribution is concerned, we looked at binomial distribution and Poisson distribution. And as far as continuous distributions are concerned, we will be looking at normal distribution. Other distribution in continuous distribution are uniform distribution, t-distribution, chi-square distribution, exponential distribution. Most widely known and used of all distribution is the normal distribution. When a large enough sample size are taken, many statistics are normally distributed regardless of the shape of the underlying distributions from which they are drawn. The discovery of the normal curve is credited to Mr. Carl Gauss. Thus, the normal distribution is at times also called the Gaussian distribution. It is also referred to as the bell curve. The area under this curve is equal to 1 and it is symmetrical on both sides. So thus, if you put it in, take half of it, the area of one side is 0.5. Now this normal distribution is asymptotic, means that this line doesn't happen to touch the x-axis. It is unimodal, that means you only have one mode, bounds up in only one portion of the graph, that is the center. The normal distribution actually is a family of curves, and every unique value of mean and standard deviation would result in a different normal curve. In addition, the total area under this normal distribution is always 1. The area under the curve yields the probability so that the total of all the probabilities for the normal distribution is 1. Because the distribution is symmetric, the area of the distribution on each side of the mean, this is mean, each side of the mean is 0.5. The normal distribution is a limiting form of a binomial distribution where n tends to infinity and neither n nor p are small. The Poisson distribution tends to a normal distribution for large values of the parameter m. The normal distribution is described or characterized by two parameters, mu and sigma. Mu is the mean, sigma is the standard deviation. The values of mu and sigma produces a normal distribution, and the density function of the normal distribution is given by this. Uh, Here the different values of sigma and mu would result into different shape or different bell curves. Using the integral calculus to determine the areas under the normal curves from this function is difficult and time consuming. Therefore, virtually all researchers use table values to analyze normal distribution problems rather than this formula. The normal or the Gaussian distribution are a family of symmetrical well-shaped density curves defined by mu and sigma. The total area under the curve is 1. So if you have a standard deviation which is large, then you can see this type of a bell-shaped curve. And if you see that the standard deviation value is less, then you can see a taller curve like this. Standard deviation happens to indicate the spread of the data. The larger the standard deviation, the larger is the spread of the data, and hence you get this kind of a shape of the bell-shaped curve. So you can see over here, if the value of mu is 15, but the standard deviation is changing from 2, 4, and 6, you can say this. This is the standard deviation 2. The mean is here, okay, 15. Standard deviation is 4. Standard deviation is 6. You can see a wider spread. Another one, you can see the standard deviation is same as 3, but the mean value is changing. So in this case, the mean is 10. Here it is 15, here it is 20. So the shape of the curve is the same, the spread is same, but only there is a shift in the mu value. So the graphs are shifting. Now this is a probability function. So no matter what the values of mu and standard deviation, mu and sigma, it should integrate to 1. Okay, to get the mean, we have to integrate the function and multiply that with the variable x. So you get the mean, and for getting the variance, you have x squared multiplied by the function minus mu square. The normal probability distribution exhibits certain properties. The distribution is symmetrical. Its Q-ness is 0. It is symmetrical. The entire family of normal probability distribution is defined by mu and standard deviation sigma. The highest point on the normal curve is at the mean, and which is also the median and the mode. Means that mean, median and mode coincide. Now the mean can be any numeric value. It can be negative, it can be 0, it can be positive. The standard deviation determines the width of the curve. The larger value of standard deviation, the wider is the curve, flatter is the curve. The probabilities for the normal random variable are given by the area under the curve. The total area under this curve is 1 and it is symmetrical, thus it is 0.5 and 0.5 on either sides. The 68, 95, 99.7 rule is a great way to approximate the areas of the normal distribution, and it works for any normal distribution no matter what shape and size. It says that 98.626% of all the values of the random variables are within one standard deviation of its mean, plus or minus one standard deviation of its mean. 95% of the data of all the values of the random variable fall in plus or minus 2 standard deviation of its mean, and 99.72% values of the random variable are within plus or minus 3 standard deviation of its mean. So if the peak actually falls at the mean, so mean median mode happen to coincide here, right? So this is where it is. Now we are saying that one standard deviations on both sides of the mean falls 98% of the values, and two standard deviation around the mean falls 95% of the values, and three standard deviation around the mean you will find 99.72% values. So the standard normal distribution is a special type of normal distribution that has a mu of 0 and a standard deviation of 1. Thus is always centered as 0, and it has intervals on both the sides that increase by 1. So you can say that a random variable having a normal distribution with mean 0 and standard deviation 1 is said to have a standard normal probability distribution. The random variable x, which is having a mean as mu and variance as this, can be written as this. Okay. Now, if you have a standard normal variate, then it can be depicted like this, which is having a mu as 0 and variance as 1. The value of z can be expressed in this way. The PDF is expressed like this, and the distribution function is depicted like this. The letter z is used to designate the standard normal random variable. Now, any distribution can be converted into a standard normal distribution. To convert any normal distribution to a standard normal distribution, this can be used. Well, we can think of z as a measure of the number of standard deviation x is from mu. The z-score is the number of standard deviation that a x is above or below the mean. So if x value is less than mu, okay, the mu lies over here where the value of z is 0. So if x is less than mu, then the z value would be negative. If the value of x is greater than mu, greater than the mean, then the z-score would be positive. And if x is equal to mu, the z-score is 0. So the standard normal density function is given like this. Now this z over here is actually x minus mu divided by standard deviation. Every unique pair of mu and sigma values define a different normal distribution. A mechanism was deployed by which all normal distribution can be converted into a single distribution, the Z distribution. This process yields the standard normal distribution. The conversion formula for the x value of a given normal distribution is given by this. So any normal distribution where mu is 60, standard deviation is 10, if I want to convert it into a standard normal distribution, I have to just plug in. When I plug in 60 over here, what happens? Z value is 0. Okay. When I plug in 50 over here, 50 minus 60, it is minus 1. Okay. So it would correspond to minus 1 z value is corresponding to 50, minus 2 z value is corresponding to 40. So now we have converted a normal distribution into a standard normal distribution. The benefit of standardization is that it allows any normal distribution curve area to be ascertained by the z-score table. The standard z-score table can be used to find probabilities for any normal curve problem that has been converted to a z-score. The Z distribution is a normal distribution with mean of 0 and standard deviation of 1. Any value of x that is one standard deviation above the mean has z-score value of 1. And 68% of all the values are within one standard deviation of the mean regardless of the values of mu and sigma. So they are between minus 1, z value minus 1 to z value 1. So 68% of the values are between this, that is 50 to 60. 68% of the values are here. Then you have 95% of the values which belong 2 standard deviations away, and then 99.7% values are 3 standard deviations away. Okay, this is how you can get it. Okay, the standard z-score table can be used to find probabilities for any normal curve problem that has been converted to a z-score. So over here this table shows that the entry for z is these entries show the area under the standard normal curve to the left of the z value. So whatever is the z value to the left of it, what is the area under the curve, that is depicted over here. So if the z value is minus 3.21, then what is the area? How do you find out? You go here, minus 3.2 you get from here and 1 you get from here. So this area is the area on the left hand side of z value 3.21. Okay, if this is 3.21, then this is the area to the left hand side of the z value. So if you want to find out the area on the right hand side of the z value, how do you go about it? To find out this green shaded area, so the total area is 1, right? So you find out the area on the left hand side from the table. So what is this? This is the area on the left hand side of 0.57. 0.57. The area on the left hand side is given by this. So if you want to find out this green area, what you will do? You will say 1 minus this area. So now you get the area on the right hand side of the z-score. Now that means once you know the area, okay, you can also find out the z-score. So suppose the area is given to you. Suppose the area is given to you as 0.8461. So what is the value of the z-score over here? So for that, what you'll do is just find this area from the table and then just correspondingly go and see the row and column values. So then it shows that the z value should be 1.02. So now some question is given to you. Okay, it talks about that maybe the score of the students is distributed this way. Mean is around 60, standard deviation is 10. Now it wants us to find out the probability that the value of x is less than 49. Okay, to find out that, what you'll have to do is first convert it into the standard normal distribution, and then see what is the z-score value. Accordingly, go and see on the table what is the area under the curve or to the left hand side. Okay, so here what are we wanting to know is what is the probability that x is less than 49. So 49 is here, so we just want to know the area, this particular area. To know that, you have to convert it into a standard normal distribution, and then from the z-score table find the area. Okay, so now what we'll do is we'll just plug in this 49 over here. Instead of this x value, you'll just plug in this 49 to find the value of the z-score. So let's see. Okay, when you put 49 over here, what do you get? Z-score value is minus 1.1. So that lies over here. So you go and see the area in the table for minus 1.1. Okay, which is 0.1357. So what we come to know, the same area is given over here also. So this is the area that we are talking about, and which is same on both in both the probability curves. So suppose it is asked that what is the probability for the z value greater than 0.92. So directly a z value is given, not an x value. So directly you can just find out from the z-score table, in fact. So what have they asked? You have to draw this diagram. What have they asked? Z value greater than 0.92 means actually they are wanting to find out this area. Now from the z-score table, actually the area on the left hand side is given to you. You can find out from the z table. So this area you can find from the z table. Now if you want to find out this one, what you will do? The total area is 1. So 1 minus this area would give you the area over here. So thus the probability for z-score greater than 0.92 is equal to 1 minus z-score value less than 0.92. Okay, and so this value can be known from the table. So we'll just see how we can. Okay, so if we see the table, we can find out that for 0.92, okay, for 0.92, this is the area, that 0.8212. So to find out this value, you say 1 minus 0.8212, which is this. Okay, let's see the next question. It says find the probability for z less than 0.976. So first let's draw this graph over here. 0.76 would be somewhere here. You want to find out z value for z value less than this. So this is the area you got to find out. So you can just go to the z table and go for minus 0.76, and this is what you find directly. Okay, otherwise at times there are tables will not give you the negative values. So in that case what you can do is to find out the from the positive value you can find out this negative value also. So for that what we can do, suppose this is the table, it is not giving you negative value, so you just find out the area under the curve to the left hand side of 0.7. Okay, 0.76. So what is the area? 0.7764. So what you can do is you can write 1 minus 0.7764. Still you'll get the same answer. So in this question, what are they asking? They are asking from the z value that ranges from minus 0.64 to positive 0.43. So if when you just draw this diagram over here, 0.64 would be falling somewhere here. It is minus on this side of moreover 0.43 is positive, so it falls over here. So this area you are wanting to find out, isn't it? So now the table happens to give you the area to the left hand side of the z value. So what you can do is to find this area, first you can find out the area on the left hand side of 0.43 and then on the left hand side of minus 0.964 and then subtract it. Okay, so if we look at the z-score table, how it looks like, we want to find out the area left of z value 0.43. So what do? You go 0.43. So this is the area left of 0.43. Okay, now here we want, what is this number? This is showing you 0.64. Okay, but this is positive 0.64, right? And we want a negative 0.64. So what we do is 1 minus this value. So this is the answer. Now we have a question wherein now x is normally distributed and the mean of x is 12 and standard deviation is 4. Now we are not been given the z value, but we have been given an x value over here. Now find the probability for the following x value greater than or equal to 20. So now this normal distribution, we'll have to convert it into a standard normal form by using this formula. So for probability, to find out the probability greater than or equal to 20, you got to use this, for which x is greater than or equal to 20, you can write that it is equal to the probability where z is greater than or equal to this, wherein wherever there is an x value, we have placed 20 there. Mu is 12, sigma is 4, as is given over here. Okay, so you just place it over here. What is the answer? This value reduces to 2. So we are saying over here, for the normal distribution where x is greater than or equal to 20 is equal to z value greater than or equal to 2. So you want to find out the probability where z is greater than or equal to 2. So you want to find out this green area. So how do you go about it? You go and see the table. Okay, when we go and see this table, we've got to find out the area to the left, to the right hand side of the z value, that is equal to 2. So what is this area? This is talking about the z values, the area to the left hand side of the z value, right? So this is the area to the left hand side of the z value, but we want to the right hand side of the z value. That's what we say is 1 minus this number. So thus we get the answer. The probability for x greater than or equal to 20 is this. To find out the probability for x less than 20, it was quite straightforward. So when you plug in 20 over here, you get 2. So probability for x is less than or equal to 20 is the same as z less than or equal to 2. So it can be directly found out from the table. Okay, this is what it is, and this is the area which is less than x is equal to 2. It's complete area. That is what we are wanting. Okay, so now we have another question which is talking about a range. So what is the probability for x between 0 to 12? So again we have to use this particular formula and convert x into the respective z value. So wherever this x is there, x is 0 here, then 12, right? So we write 12 here. So 0 minus 12 by 4. So z value should be between this and this value. Okay, so what is it coming to? This is reducing to minus 3, this is reducing to 0. So now we have to find out the area between the z value minus 3 to 0. So let's go and see the table to find it out. So if you see the table over here, it shows that -3 less than area left to -3 value is 0.0013. So now we want the area only from -3 to 0, right? And this area is what? Area to the left of -3. So the total area over here is what? Is 0.5, right? This area is 0.5. So we are just subtracting this particular area from 0.5 to get this shaded area, which is equal to 0.4987. So in this question, what is given to you is the probability is given to you. You have to find out the number over here. X is greater than what number? Okay, means now till now you were having a question now where find out the probability for X is greater than 20. So now yet this 20 is not given here. Instead, the probability is given. Find out the value of X bar. So how do you go about it? Definitely you for any X bar to convert it into the corresponding Z value, what do? You just use this particular formula, right? The X bar minus 12 divided by 4 is equal to 0.24 is given to you. Now what is this 0.24? It is actually the area to the left hand side of a Z value, isn't it? It is left hand side of a Z value. Okay, now what is here? Is it greater than or less than? It is saying that Z is greater than equal to this number. Okay, so now this 0.024 is the area greater than Z is equal greater than the Z value, right? So what is this other area then? This is 1 minus 0.24, which is equal to 0.76. Okay, so now what is 0.24? It is saying that Z is greater than this number, right? So 0.24 is the area over here. So to find this particular area, what you do? You say 1 minus 0.24, that is 0.76. Now 0.76, this area corresponds to what Z value? So you go to the table and just see where is this number, 0.76. So you see that this number is closest to 0.76. Thus you say that the Z-score corresponding to this is 0.71. Okay. So now we got to find out the corresponding X value. So now we want to find out the corresponding value of X for which the Z value is 0.71. So this X value you got to find out. So what we find out from by solving it, that X is equal to 14.84. So thus we have found out the answer to it. Okay, let's see another question. The yield, mean yield for a 1 acre land plot is 662 and standard deviation is 32 kilos. Assume normal distribution. How many 1 acre plot in a batch of 1000 plots would you expect to have yield over 100 kilos and below 650 kilos? So how do you interpret it? So X is following a normal distribution. Mu and standard deviation is this. Now, what is it asking? What is the probability for X is greater than 700? Okay. So now we have to convert it into standard variant, standard probability. So 700 minus 662 divided by 32, you get 1.1875. Now here you have to find out the area. Now it is Z greater than this. So actually you are going to find out this green area, right? Now from the table you'll get this area, okay, on the left hand side. So you'll have to do 1 minus this area. So where are you getting this from? From the Z table we can see that for Z value 1.18, okay, you are getting the value 0.8810. So now we are doing 1 minus 0.8810, it comes up to 119. Hence, in a batch of 1000, the expected number of plots with yield over 700 kilos is 1000 multiplied by this. The next question is about below 650. So we got to solve it this way. Now here it is talking about the area under the curve on the left hand side, and that is what you get from the table. So if you look at z value minus 0.37, you get 0.3557. So directly we can take it. Hence, in a batch of 1000, the expected number of plots with yield 650 kgs is 1000 multiplied by 0.3557, which is equal to this. Okay, let's look at another question wherein if the heights of 1000 students is normally distributed with 65 inches and standard deviation 5 inches, estimate the number of students having height greater than 70 inches. So, so this is what it is. Mu is 65 and the standard deviation is 5. Now what are we wanting to find out? The probability that x is greater than 70. So we are going to find out the z value corresponding to it. So what we get is z is greater than or equal to 1. So we go and see the area from the table for z is equal to 1 is 0.841. Okay, now we are wanting which side of the which part of the area. Actually we are talking about z greater than this point, isn't it? Z greater than this one. So we are talking about this green area. So from the table, this area that you get is the area from this point towards the left. So you will have to do 1 minus this area that you get from the table. So 0.158 is the area which is shown by the green color. Hence, in 1000 students, the expected number of students having the height greater than 70 inches is, this is what you have calculated as a percentage. So you multiply it by 1000 to get the count. Since we cannot have a count of people in numbers, we can just approximate it. And it may say that 158 people are estimated. Thank you, students. With this, we'll end this module of normal distribution.